Hello, friends. Welcome once again to 7 Sense Aptitude Prep. I'm your friend Vinod Prabhu, and this is the fourth video on mixtures and alligations. Here we are going to look at actual problems in the exam, problems that are tougher than what we have seen until now, and problems which typically look at two concepts in one. Okay, so I'll explain what I mean by two concepts in one. Trying to solve profit and loss questions using mixture and allocation. Trying to solve simple interest, compound interest questions using mixture and allocations. Those are some of the exam problems that we will encounter and we will see how to solve them. Okay, so problem 16. In a pot, there is a mixture of milk and water in the ratio 4:5. If it is filled with an additional 8 liters of milk, the pot would be full. And then once the pot is full, the ratio of milk and water would become 6/5. Find the capacity of the pot. So what it says is, let us say there is a pot with a capacity P. Initially, what is the amount of mixture in the pot initially? So let's say that this is initial. Initially, we have only P minus 8 in the pot, because if you add 8, it would have become P and full. Now, it has only P minus 8. What is the quantity of milk in that? Total mixture is P minus 8. Milk and water are in the ratio 4:5. Don't write 4 by 5. It has to be 4 divided by 4 plus 5. Meaning 4 by 9 into P minus 8. Okay. Milk and water are in the ratio 4:5. So quantity of milk is 4 by 9 into total mixture. Total mixture is P minus 8, because if you had added 8, it would have become full and P. Now on the RHS. After adding 8 liters of milk, the ratio of milk and water is 6/5. Okay. So this is initially and this is later. Now when you add 8 liters of milk, what happens to the mixture? Initially it was P minus 8. When you add 8 liters of milk, it becomes P. Okay. What is the ratio of milk in this? Is 6/11. So see here we have taken 4:5 and made 4 by 9. 6:5 we made it 6 by 11 into P, because we have added 8 liters here. Previously 8 liters was less. Now what do we do? How do we equate? Can we equate? We can't equate. So we have looked at the quantity of milk initially, quantity of milk later. We can't equate because milk has been added. So how can I equate? On the RHS, if I remove the 8 liters of milk, would it not be the same as the initial quantity of milk? So from this, so this is the new quantity of milk. If I subtract 8 liters of milk from this, it should be equal to the initial quantity. So I repeat, initially the can has a capacity of P. It has 8 liters less. Okay, because adding 8 liters of milk, it would make it full. So it has 8 liters less. So P minus 8. Quantity of milk in that mixture is 4 by 4 plus 5 into P minus 8, which is 4 by 9 into P minus 8. When you add 8 liters of milk, the quantity of the mixture becomes P, and the ratio of milk in that becomes 6 by 11 into P. So we have got an initial and we have got an later. So how do I equate it? Subtract the quantity of milk added. So this is quantity of milk. This is quantity of milk later. If I subtract the 8, it will make it equal to the quantity of milk earlier. So if I have to simplify, 4 by 9p minus 32 by 9, okay, is equal to 6p by 11 minus 88. Okay, we get this. Okay, on simplifying we get 44p minus 32, 10, 320, 352. So it's equal to 9 into 654p minus 88 into 10 is 880. Subtracting 88 from there is 792. Okay, this is 10p. So 792 minus 352 is 440. P is equal to 44 liters. Initial capacity is 44 liters. So we let us see whether what we have solved is correct. Okay. 44 liters is the capacity, so it was 8 liters less. So initially we had only 36 liters. Okay, 36 liters. In 36 liters we had milk and water in the ratio 4:5. So we got 4 by 9 into 36, which is the quantity of milk. 9 1 9 4, we had 16 liters of milk initially. Now I've added 8 liters of milk, so milk became 16 to, so if it was 16 liters of milk, we had 20 liters of water initially. Now I add 8 liters of milk. 8 liters of milk, meaning this became 24 liters of milk. Water remains 20 liters of water. Is this in the ratio 6:5? 24:20 is in the ratio 4:6 and 4:5, 6:5. So our answer is indeed correct. Rupees 1500 is invested in two schemes. One scheme gives a return of 5% and the other scheme gives 1% more. Okay, if the total interest income is 85 at the end of 1 year, how much is invested in each scheme? So this is a combination of simple interest problems that is solved in Mixures and Alligation method. So 1500, what does the return of 5% mean? 1500 into 5 by 100. So 1500 if you invest and you're getting, let's say, interest income of 5%, it means you are getting 75 rupees at the end of the year. This is scheme 1. In the second scheme, you are getting it at 1% more. Okay, not 1%, 1% more. So 1500 into 6 by 100. If you had invested in second scheme entirely, you would have gotten 90 rupees. Scheme 2. But he's invested some part in scheme 1, some part in scheme 2. Okay, and he's gotten 85 at the end of the year. So what do? You do lower, okay, price of lower, price of higher. So this is like the mixture, right? So he's invested some part in 1, some part in 2, and he's mixed. So which is the price of the mixture? You will get the quantity of lower and quantity of higher. So 75, 90, 85 gives me 5 and 10. 5 and 10 is 1:2. It means quantity, or rather amount in the lower scheme, in scheme 1. Okay, lower scheme is scheme 1, no? See, this is lower. So amount in the lower scheme by amount in the higher scheme is 1/2. So how much is invested in each scheme? In the lower scheme, I'll have 1/3 into 1500. This is lower, which makes it 500 rupees. And in the higher scheme, I'll have 2/3 into 1500, which is 1000 rupees. So if I invest in this ratio, 500 in the lower scheme of 5% and 1000 in the higher scheme of 6%, I will get 85 rupees at the end of the year. So here you will see a simple interest problem being solved in the Mixures and Alligations method. Let's look at the next question. Biker covers 100 kilometers in 6 hours, but it is on two different bikes. On the faster bike, he travels at 20, and on the slower bike, he travels at 15 kilometers per hour. And the distance covered on the slower bike. So here we'll see how we can use Mixures and Alligations to solve problems in time, speed, and distance. We will get this speed slower, speed faster, speed total. Okay, we'll give you distance covered on the slower bike and distance covered on the faster bike. Distance on the faster bike. So what is speed slower? Speed slower is 15. Speed faster is 20. Speed total. What is speed total? Have they given? Yes, they have. They said 100 kilometers in 6 hours. So 100 kilometers in 6 hours is the total. You can get the total speed there. So this is total distance, this is total time. 100 by 6 will give you 16.66 as the total speed. So I write 16.66 here. And when I do annihilation with this, I'll get 3.33. Then I get 1.66. What does it mean? Distance covered. This is distance lower. Distance lower by distance faster is in the ratio 3.33 is to 1.66, which is 2 is to 1. So what is the total distance? 100. So you'll have to find out the distance covered on the slower bike. So distance covered on the slower bike is 2 divided by 2 plus 1 into 100. So 2 by 3 of 100, you will get 66.66. So distance by the faster bike, if they had asked that, this is the answer here. Slower bike, they asked the distance on the faster bike, 1 by 2 plus 1 into 100, 33.33. You can quickly verify that these two together add to 100. These two should together add to 100. Even here we know there is one with the lower speed, one with the higher speed. Your average speed for the journey, okay, can't be lower than this, it can't be higher than this. So it will have to follow Mixures and Alligations rules. Let us look at this problem, which is a commonly asked type of problem called the zoo problem. A boy visits the zoo, he counts 100 heads, but only 250 legs in one enclosure. Now the zoo has, this enclosure has only parrots and hippos. So how many parrots and hippos are there? So if there are only parrots and hippos, each of them, parrot has only one head, and then the hippo also has one head, right? So this is one head, this is one head, but the parrot has 2 legs and the hippo has 4 legs. Okay? So just remember this. Now, if it was all parrots, we would have had 100 heads and 200 legs. Okay, if it was all parrots. If it was all hippos, we would have had 100 heads and 400 legs. If it was all hippos. Now, the mixture of parrot and hippos is 100 heads and 250 legs. So, taking the heads is not useful because we have 100 in total everywhere. If it was only parrot, it would be 100. If it was only hippos, we would have 100. Now, the mixture also we have 100. Now, let us look at legs. Okay, so if you take legs lower, which is legs of parrot, and legs of hippo, the legs of total animals in this enclosure will give you ratio of parrot, as in quantity number of parrots. Will give you this ratio of parrot, and then the number of hippo. Will give you ratio of parrot to ratio of parrot to hippo. It will give you this ratio. Now, legs of parrot, if it was only parrot, would have been 200. If it was only hippos, would have been 400. Now you have 250. Okay, taking heads, like I said, all of them have only one head each. So taking the legs will help us to solve how many parrots and hippos are there. Here, when you do mixtures and alligations, you get 150. Here, 250 minus 200, you get 50. When you take this ratio, then the ratio 3:1, which means parrots and hippos are in the ratio 3:1. This was parrots. This is hippos. What do I mean when I say they are in the ratio 3:1? So if we look at X number of, I know total number of animals, so I'll have number of parrots is equal to 3, because this is the parrot side, right? I'll have 3 divided by both of this, 3 plus 1. Okay, I add in the denominator, into what number should I multiply here? Into 100, because there are only 100 animals there, because 100 heads are there. So I'll get 3 by 4 into 100, I'll get 75 parrots. And similarly for hippos, if they had asked hippos, I would have gotten 1 divided by 3 plus 1 into 100. I would have gotten 25 hippos. Okay, now let's see for 75 and 25 hippos, we get 100 heads. Let us see how many legs we get and to verify. So 75 parrots will give me 75 into 2 legs, which is 150. And 25 hippos will give me 25 into 4 legs, which is 100. And I get 250 legs. Hence, verify. So number of parrots is 75. Number of hippos, 25. We look at one problem on profit and loss, which can be solved using mixtures and alligations. During Bakri, a man purchases 2 goods for rupees 2000 in total. Okay, remember whether it's 2000 each or in total. Okay, both these goods together, he has paid 2000. On one good, when he sells, he incurs a loss of 10%, and on another good, he incurs a profit of 15%. And overall, there is no profit or loss. See, totally, goat 1 plus goat 2, cost price of goat 1 plus cost price of goat 2 is 2000. Then selling price of goat 1 plus selling price of goat 2 is also 2000. Okay, that is what it says. Now, on one of these goods, okay, on this goat, let us say if he has incurred a transaction of 10% loss, on this he has incurred a transaction of 15% profit. Okay, on one goat he has incurred a loss, and another goat is incurred a profit, so that overall he has not made any profit or loss on the transaction. Here what we can do, losses in mixtures and alligations are taken as minus, and profits in mixtures and alligations are taken as plus. So, and no profit, no loss becomes 0. So if I write that here, loss percentage, okay, profit percentage, okay. Because here it is loss and profit. If both are profits, you write plus on both the sides. Will be the total loss or profit, total loss slash profit will be the price. You get the ratio of the prices. Price of the one that is selling it at loss, price of the one is selling it at profit, and you can take that ratio. Loss percentage we have gotten as 10% minus, so I write minus 10. Profit percentage is 15, and overall there is no loss or profit, so I write here as 0, which means this is 15, this is 10. So it is 3:2. 3:2. So price of the one that he is selling it at loss, so I get price, the one is selling it at loss, my price of the one selling it at profit are in the ratio 3:2. 3:2 of how much? Of the total price. What is the total price? 2000. So if I have to find the price that is selling it at loss, I do 3 by 3 plus 2 into 2000, which is 3 by 5 into 2000, 1200. And price at profit similarly will become 2 by 3 plus 2 into 2000. And this is 800. So on how much does each course cost? Now we have to see how much does each course cost. So 1200 and 1800 is what each course costs, which he will now sell it at profit and loss. Okay, we have looked at in this, we have looked at this is the cost price, right? This would also be the cost price of each of the goods. This is the good that will sell at a profit. This is the good that will sell at a loss. Okay, this is the good that will sell at a loss. So it is costed him 800. The one that he will sell at profit is costing him 800. The one he will sell it at loss is going to cost him 1200. Can we verify? How do we know whether we gotten the right answer? So let me just make some space here. He is selling the goat which costed him 800 at a profit of 15%. How do we do that? Selling price there equal to 800 into 1 plus 15 by 100, which is 800 into 1.15. You can calculate that here. 1.15 into 800, 0.040. So this he is selling it at 920. So the goat that he purchased at 800, he is selling it at a profit. What is the profit? 15%. I get the selling price as 920. This is the selling price of goat 1, which is the profit making goat. Selling price on goat 2 is 1200 into it's a loss. This here. So which is 0.9 into 1200. 1200 into 0.9. So selling price of both the goat, cost price of both the goats are 800 and 1200. Together it is 2000. Selling price of both the goats are 920 and 1080 respectively. If I add this, I'm getting 2000 rupees. So the cost price of both the goats combined is 2000. Selling price of both the goats combined is now 2000. I'm making profit on one goat of 15%, making loss of one goat, which is 10%. But overall, I'm not making any profit or loss, which is what the question says. And the cost price of the goat will be 800 and 1200. If that asks what is the selling price of each of the goats, I would have gotten these two values. So friends, we've looked at a few videos in Mixures and Alligations, starting from the basics to as in the concepts and some basic problems. Then we moved on to intermediate problems, we moved on to the tough problems, and in this video we looked at questions that are answered in exams that are an application of two or more areas. Okay, so we looked at how zoo problems could be done in profit and loss. We looked at how profit and loss problems could be done in profit using mixtures and alligations. We looked at speed, time, speed, and distance problems that could be done in mixtures and alligations. So we've looked at all of these different areas that could be solved using mixtures and alligations. It's a very, very handy tool, and using this, a lot of computational work will be avoided and answers would be gotten. Remember the alligation rule always. Okay, you remember at what in what direction you will have to subtract, and remember that entire rule and practice a lot of problems. Okay, practice, practice, practice. That is the only way to get better at aptitude. And if you like this video, click on the thumbs up button, subscribe to our channel, and click on the bell icon and share it with your friends. People who haven't heard of us, please do share. And if you have any doubts or if you have any words of appreciation or feedback, please put that in the comments. And if you need more help with the practice company specific questions, the module based questions, you can visit our website 7sensetalent.com and sign up, login, and then practice there. I want to thank you for spending your time with us, and I hope you practice well on mixtures and alligations. All the best.